Good morning, everyone. Hope you have understood the last lecture. I had given you an introduction for the formulas and the trigonometric ratios, right? Keeping in mind all those formulas, today we are going to do a very important topic of this chapter, that is trigonometric identities. Yes. Now, in order to understand trigonometric identities, it is very important for all of you to refer to the previous video and revise the formulas. If you have not gone through the video, I would suggest please refer the first video, because unless and until you don't have that base, you won't be able to understand the identities part. So if you are still confused, pause that video, revise the formulas, previous formulas, and then go ahead with the video, right? Okay, so I will tell you. Right. In all, we have three main identities. Okay, three main identities are there, and out of those three identities, we have six sub-identities. Right. Now, we'll not go into the proving of the identities because it never comes. You just need to learn and know these identities and where should we apply it. So the number one identity that we have today is sine square theta plus cos square theta is always equal to 1. Whenever in a question, if you come ahead with this particular sort of an expression, sine square theta plus cos square theta, simply put it as 1. It is always equal to 1. Now, the sub-identity for this main identity is, can I say that, okay, if sine square theta plus cos square theta is equal to 1, therefore sine square theta is equal to 1 minus cos square theta, and cos square theta will be equal to 1 minus sine square theta, right? These are your sub-identities. The second identity that we have today is 1 plus tan square theta is equal to sec square theta. Identity number 1. This is your main identity number 2. What is it? Tan square theta is 1 plus tan square theta is equal to sec square theta. So the two identities which I can have is, okay, if this is the situation, then tan square theta is equal to sec square theta minus 1. Simply we bring this one from here to here. Secondly, can you say that sec square theta, if I bring tan over this side, sec square theta minus tan square theta equal to 1. So again, these are the two sub-identities. Nothing, you just have to bring one term from LHS to RHS. That becomes your sub-identity. Now, the third identity that we have is 1 plus cot square theta is equal to cosec square theta. Second was 1 plus tan square theta is equal to sec square theta. Third is 1 plus cot square theta is equal to cosec square theta. So the sub-identities that we have, again in the same manner, cot square theta will be equal to cosec square theta minus 1. Secondly, can I write that cosec square theta minus cot square theta, I'm bringing the cot from here to here, equal to 1, right? So these are your sub-identities for the main identity 3. Number 1, sine square theta plus cos square theta equal to 1. Number 2, 1 plus tan square theta is equal to sec square theta. Number 3, 1 plus cot square theta equal to cosec square theta. Now it is very important for all of you to learn these identities by heart. Otherwise, you won't be able to solve any of the questions that we are going to do after this, right? Now, as far as identities are concerned, you have two types of questions that would be coming. One type of question I will be dealing with today. Second type of questions I will deal it with in the next episode, episode 3, that is proving type of questions. LHS would be given, RHS would be given. You have to say that LHS is equal to, you have to prove basically using the identities and formulas, you have to prove that LHS is equal to RHS. Right. Now let's see first type of questions. Right. See, if any one ratio is given to you, using the identities, it is possible for all of us to find out the remaining 5 ratios. You know, how many ratios are there? 6 ratios are there. So out of these 6 ratios, if any one ratio is given, it is possible for us to find out the other 5 ratios using identities, right? Now, what is given to us? The question says, if sine theta is equal to 7 upon 25, find the values of cos theta and tan theta. Now, we know what is given to us. Sine theta is given 7 upon 25. What do we need to find? We need to find a cos theta. Now, I have an identity with sine and cos, so I will write down sine square theta plus cos square theta equal to 1. What do I want? I want cos theta, so I'll keep it over here on the LHS side. Cos square theta is equal to 1 minus sine square theta, and hence cos theta is equal to under root of 1 minus sine square theta, right? So now let us find out cos theta. Let us substitute the value of sine theta. Cos theta equal to under root 1 minus sine square theta, so 7 square upon 25 square cos theta (1 minus 49 upon 625), right? Square root of. Now let us solve this and find out the value of cos theta. After solving this, we get root 576 upon 625. Taking a square root, we will get square root of 576 is 24, 625 is 25. So cos theta is equal to 24 upon 25. We got the first value. Second, they have asked us about tan theta. Now, no need to use the identity for this because we have a direct formula that tan theta is always equal to sine theta upon cos theta. Sine theta, it's given 7 upon 25 divided by 24 upon 25. 25 gets cancelled. So therefore, tan theta is equal to 7 upon 24. Right? That's the way to solve such type of questions. Okay, so this is the first step. If one ratio is given, you can find out the other 5 ratios. This is the first type of question using identities. Question number 2 says, see, tan theta is given, you have to find out the values of sec and cos, right? Tan is given to us. Now, what do you need to find out? You need to find out sec. And do you have an identity with tan and sec? Yes, we do have. What is the identity? Identity says 1 plus tan square theta is equal to sec square theta. We have tan, so let us find out, put in the values. 3 by 4 whole square is equal to sec square theta. So therefore, sec square theta is equal to 1 plus 9 upon 16. This is equal to 16 plus 9 upon 16, which is equal to 25 upon 16. Sec square. Now, what will be sec theta? Therefore, sec theta is equal to square root of 25 by 16. Hence, sec theta is equal to 5 upon 4. Right? This is the thing. Now, when this is given, now we found out the first thing, that is sec theta. Now, second thing what I have to find out is cos theta. Now, do we use of identity? No, it's not possible. I mean, it's not necessary to use the identity because we know sec and cos are reciprocals of each other. Cos theta is always equal to 1 upon sec theta. So, which is equal to 1 upon 5 by 4. This 4 will go up. So, therefore, cos theta is equal to 4 divided by 5. That's it. You've got the answers. Quite simple. Yes. Third one. It says cot theta is given to you 40 upon 9. You need to find out the values of cosec and sine. Cot is given. What you have to find? Cosec. And we have an identity of cot and cosec. Yes. Let's write the identity first. Cosec square theta is equal to 1 plus cot square theta, or 1 plus cot square theta is equal to cosec square theta. You say in any way, doesn't matter. So just put in the values of cot square now. 40 upon 9 the whole square. So this is equal to 1 plus 40 square will be 1600 upon 81. We need to take an LCM. So 81 plus 1600 the whole upon 81. Let us solve this and find out the value of cosec. So this is the value of cosec theta we got, 41 upon 9. That's the first thing we have to find out. The next we have to find out is sine theta, and we know cosec and sine are reciprocals of each other. So therefore we will directly write sine theta is equal to 1 upon cosec theta. So hence sine theta will be reciprocal of this. So 9 upon 41. That's the value needed. Next question. It says now, see, this gets a little tricky now. It's nothing tricky, it's just simple rearrangement. What is given to you? 5 times sec theta minus 12 cosec theta equal to 0, and we have to find these values. Okay, so let us write what is given to us. 5 sec theta, 12 cosec theta equal to 0. What we'll do, we'll bring this over here, so negative changes to positive. So therefore 5 times sec theta is equal to 12 times cosec theta. I'll bring this 12 over here and sec over here. 5 upon 12 is equal to cosec theta upon sec theta. Okay, right. What do we have? Therefore, what is cosec? Cosec is 1 upon sine. What is sec? 1 upon cos. So it gets interchanged. So therefore 5 upon 12 is equal to cos theta upon sine theta. So what do we have? This is equal to cot theta. So therefore cot theta is equal to 5 upon 12. Now, is this required? No, this is not required. So if this is not required, what do we have to find? We have to find sec, cos, and sine, right? We have an identity of cot and cosec together, and if we find out cosec, we will be able to find out sine. With sine, we can find out cos, and if cos we got found out, we just reverse it, let's take a reciprocal. So let's try solving this. So with cot, we have identity 1 plus cot square theta is equal to cosec square theta. Let us put in the values. 1 plus 5 square upon 12 square equal to cosec square theta. So let us solve this. Solving this, we got the value of cosec theta as 13 upon 12. Now, as we know, cosec and sine are reciprocals of each other, so therefore, can I write that, okay, sine theta is equal to 1 upon cosec theta, which is equal to 12 upon 13. So we got one value, sine theta, right? Now, as I have sine theta, I can directly find out the value of cos theta, and we know, according to the identity, that cos square theta is equal to 1 minus sine square theta. So let us solve this substitute. I'll substitute the value. So this is equal to 1 minus 12 square upon 13 square. Just putting the calculations short, this will be equal to 169 minus 144 upon 169. Cos theta is equal to under root of 25 upon 169. So therefore, cos theta equal to 5 upon 30. So this is the other thing that we wanted. So we got cos, we got sine, now we want sec. So sec is nothing but reciprocal of cos. So therefore sec theta 1 upon cos theta, sec theta is equal to 13 upon 5. Those are the three answers that we wanted, right? Okay, now what is given? Tan theta is given as 1. Find the values of sin theta, cos theta. Okay. Now see, when such things come, first you have to find values of sin theta, cos theta, sec theta and cosec theta according to tan theta. Now let's say tan theta is given and tan and sec has identity. We know that 1 plus tan square theta is equal to sec square theta. Putting in the value of tan, can I not find out the value of sec theta? Yes, we can. So therefore, sec square theta is equal to, tan theta is equal to 1. So 1 plus 1 square, that is going to be 1 plus 1, that is going to be 2. So therefore, taking square root, sec theta is going to be root 2. So this is sec theta. I also want cos theta, right? So cos theta will be reciprocal of sec theta. So cos theta will be 1 upon root 2. Quite easy. Now using cos, can I not find out sine? So we know that sine square theta is equal to 1 minus cos square theta. So this is equal to 1 minus cos square. So it will be 1 by 2. 1 minus 1 by 2 is equal to again 1 by 2. So sine square theta is equal to 1 by 2. So therefore, sine theta is equal to 1 upon root 2. And as sine theta is known, taking reciprocal of that, we can find out cosec theta. So cosec theta, 1 upon sine theta. Cosec theta is equal to 1 upon 1 by root 2. So root 2 will go up, root 2. Right. Now just this is what we need to find out. So let us write that and just substitute the values. So sine theta plus cos theta, the whole upon sec theta plus cosec theta. So sine theta is what? 1 by root 2 plus cos theta is also 1 upon root 2. The whole upon sec theta is root 2 plus cosec theta is also root 2. So 1 by root 2 plus 1 by root 2 is basically, can I write it as 2 times 1 upon root 2? Okay. Same, root 2 plus root 2, again 2 times root 2. 2 gets cancelled. We have 1 by root 2 upon root 2. This root 2 will come up, go down. So this is 1 by root 2 into 1 by root 2. So root 2 to root 2 is 2. Hence, this entire thing is equal to 1 upon 2. So the value of this is 1 by 2. Okay, getting me? It's quite simple. Right, let us go to the next. Okay, now see, express the ratios. This is again another important different type of question. Express the ratios cos A, tan A, sec A in terms of sin A. We have to express all this in terms of sin A. Okay. Now, cos in terms of sin A is simply, so number 1, we have cos square, the identity of cos A, we have cos square A is equal to 1 minus sin square A. Cos A is equal to under root 1 minus sin square A. So that's the first thing that we wanted, cos A in terms of sin A. Next we want tan A. Okay. Tan A, we know what is tan A. Tan A is equal to sin A upon cos A. Okay, again, you have to convert this into A. Right. So sin A numerator will remain same because already it is in sin. Cos A will take this value. So sin A upon 1 minus sin square A. So this is your second. Tan A is equal to sin A upon 1 minus sin square A. And then we have sec A. Now sec A is what? Sec A is 1 upon cos A. And cos A in terms of sin is this. So we just need to substitute the value of cos A. Sec A is equal to 1 upon under root 1 minus sin square A. So this is the third thing I want. So cos A, tan A, and sec A, we have written in terms of sine. That means that is equal to your RHS should consist of only of sine terms, not any other ratios, right? Let's see one more question like this. Now, this question says express trigonometric ratios of sine A, sec A, tan A in terms of cot A. Okay, so that means your RHS should consist only of the cot ratios. Right, now how do we go with this? Okay, let us do step by step. Now, cot A. Now, what is the identity of cot? Cot is with cosec. Okay, so we know according to the sub-identity, cot square A is equal to cosec square A minus 1. Or we could use the normal identity, that is 1 plus cot square A equal to cosec square A. So therefore, cosec square cosec A, not square, we'll take the square root. Therefore, cosec A is equal to under root of 1 plus cot A. Okay, this we got as cosec. Cosec is under root of 1 plus cot square A. And what is reciprocal? Cosec A equal to cosec A is equal to 1 upon sine A. 1 upon sine A is equal to under root of 1 plus cot square A. So what we need, first thing is we need sine. So therefore just interchange the places. Sine A is equal to 1 upon square root of 1 plus cot square A. So this is the first thing that we wanted, sine A in terms of cot A. Right. Now we got sine. We require cos now. And how do we get cos? Cos and sine, we have sub-identity. We know that cos A is equal to under root of 1 minus sine square A. Cos square is equal to 1 minus sine square. So cos A is equal to root of 1 minus sine square A. And in this sign, we will put up this value. Okay, in this sign, we will put up this value. Cos A equal to under root of 1 minus, it is in square terms, so square root 1 plus cot square A. So we will just cross multiply over here. So 1 plus cot square A minus 1 whole upon 1 plus cot square A. So plus minus gets cancelled. This is equal to square root cot square A upon 1 plus cot square A. This numerator can be root and square can be cancelled. So therefore finally what do we have? We have cos A is equal to cot A upon square root of 1 plus cot square A. This is the second thing that we wanted, sine A, cos A. And if we have cos A, the second thing that we wanted was sec A. So we just take a square root, reciprocal. We know sec A is reciprocal of cos. So sec A will be under root of 1 plus cot square A whole upon cot A. So we expressed sec A wholly in terms of cot A. Now, third last thing we want is tan A, and we know we have sine, we have cos. Tan A is equal to sine A upon cos A. So this is equal to sine A is 1 upon root 1 plus cot square A. The whole upon cos A is cot A again under root 1 plus cot square A. So this and this gets cancelled. So we simply have, and obviously tan and cot are reciprocals of each other. So we can simply write tan A is equal to 1 upon cot A. No need to do all these things also. Just simply write this tan in terms of cot. Okay, this is the way we do it. Same way, I think now you can express this also, write all the trigonometric ratios of angle A in terms of sec A. Yes. So let us start with this as well. Sec, we have identity of sec and tan. So 1 plus tan square is equal to sec A. So therefore, tan A is equal to under root of sec square A minus 1. First thing we got. Now directly we can write cot A as well, just reciprocal of this. So therefore, cot A will also be equal to under root of 1 upon square root of sec square A minus 1, because it's the reciprocal. Now cos, you know, cos is what? Cos A is equal to 1 upon sec A. You've got this. You've got cot, and now cot and cosec, we have an identity together. 1 plus cot square A is equal to cosec. So because if we get cosec, we will get sine as well. So just substitute the values and find out the value. Find out these. So therefore we get cosec A is equal to sec A upon under root of sec square A minus 1, right? This is what we got, cosec A in terms of sec, and just the reciprocal of this will give us sine. So therefore sine is equal to, in this case, I'll just write it quickly over here, just a reciprocal, that is under root of sec square A minus 1 upon sec A. Easy, simple. So only one sec A, so other 5 ratios, tan A, cot A, cos, sine, cosec, we have written solely in terms of sec A now. Okay, so these were some few questions. Do practice them. Next class or next episode, we are coming with proving type of questions, which is the heart of trigonometry. Okay, proving type of questions, very important from all, be it state, CBSE, ICSC, from all your board examinations point of view. Proving type of questions are going to be very important. Okay, so if you have liked the video, if you've understood the video, please hit that subscribe button, like the channel, like the video, and share it as much as possible. Thank you. See you soon. Bye bye.